Hey, how's it going, everybody? In this video, we're going to be looking at a few common scenarios in Git where you can find yourself needing to undo some mistakes or even roll back some bad commits. Now, some of these commands will change the Git history and some will not. And we're going to take a look at exactly what that means here in a second. Now, this will be a slightly more advanced Git walkthrough, and we're going to assume that you already know the basic command line functionality of Git. If you aren't familiar with basic Git commands or how Git works, I do have a video on getting started with Git in the command line if you would like to watch that video first. But with that said, let's go ahead and get started. So let's take a look at the sample repository that I have set up here. So if I do an ls-la within this directory, you can see that I have this calc.py file. And I also have that calc.py file pulled up in my text editor over here. And you can also see that we have the .git directory here, which just means that we are within a Git repository. So now if I run a git status, you can see that currently our working directory is clean. If I do a git log, then you can see that we've only had one commit so far. It's just the initial commit. And also if I run a git branch, you can see that we have another branch here called subtract feature. So both the subtract feature branch and the master branch are currently exactly the same. They both only have that one initial commit. But for now, we're not going to bother with the subtract feature branch. We'll take a look at that here in a little bit. So let's look at our first example of a mistake that you might want to undo. So first, we're going to say that we've made changes to a file, and after a while, we realize that we don't want any of the changes that we've made. So whatever we've done, it just isn't right, and we want to go back to the way things were. So for this example, I'm just going to type in a bunch of gibberish here into the text editor. But more realistically, in the real world, this would likely be a bunch of code that for one reason or another just isn't right, and you want to go back to the way that things were. For this example, if I go over here and do a git status, you can see that we have modified the file. If I do a git diff, you can see all the gibberish lines that we've put in there. Now, the way that we can fix this is to just use a simple git checkout. So what I'm going to do here is a git checkout calc.py, and if I hit enter there, now if I do a git status, you can see that our working directory is clean. And if I do a git diff, you can see that we don't have any changes. And if I go over here to the file and this reloads over here, you can see that we are back to the way that things were after we made our initial commit. So now let's actually make some changes to our file that we do want to commit to our repository. So I'm going to come in here and change the subtract function, and I'm just going to do a return x minus y. So that's what we want. So now I'm going to go back over here to our terminal. Now if I run a git status, you can see that the file has been modified in the working directory, and I'm going to add that to the staging area. And now if I do another git status, you can see that that file is ready to be committed. So now I'm going to go ahead and commit this file. But let's say that we make a git commit and accidentally mess up our commit message. So I'm going to say that we completed the multiply function, which is wrong because we completed the subtract function. So I'm going to go ahead and commit that with the bad commit message. So now if I do a git log, you can see that we've made the commit, but the message is wrong. So how do we modify this message without doing another commit? Well, to do that, we can just do another commit with the -- amend option. So if I do a git commit -- amend, then I can type in -m for my message, and I'm just going to say completed subtract function. So now if I do a git log here, you can see that we haven't added any more commits. We still just have the 2 commits, but we have changed this commit message on our last commit, which is what we wanted. Now I do need to point out that this unique hash here is different than it was before we changed the commit message. Now that's because the commit message is part of the commit, and changing it will also change the hash. And when the hash changes, that means that it changed the get history. So we only want to ever change the get history when we are the only ones who have had access to the changes that we've made. So if we've pushed our changes for other people to see and pull from, then we do not want to change the get history because it can cause problems with their repositories. So later in this video, we're going to look at some ways in which we can make corrections without changing the get history. But as long as we're the only ones who have seen our changes, then changing the history isn't necessarily a bad thing, and it also makes for cleaner commits. So in the case of a bad commit message, this is likely something that you'll notice right away and can fix it right on the spot like we just did. Now, kind of a similar scenario is that instead of accidentally committing the wrong message, let's say that we accidentally left off a file that we meant to commit. So in this example, let's say that I meant to create a getignore file and I wanted to add it to that last commit. So I'm going to create a .getignore file here. And now let me go ahead and run a get status, and also let me add that to the staging area. So I'll do the get add.getignore. So now it's in our staging area, but we don't want to make a new commit. So for this example, we're saying that we wanted that to be a part of the last commit. So again, we're just going to do the get commit -- amend like we did before, but this time it's going to do it with a file. So if I hit enter here, now it's going to bring up this interactive editor where we can change the get commit message if we want. Now notice here that this is the same get commit message from our previous commit. Now we don't want to change the message in this case, so I'm just going to save and close out. So now I'm going to do a get log, and you can see that we still just have the two commits that we had before. Now if I do a get log -- stat, this will show us the files that were changed within the commit. And you can see here that the getignore file is now part of the last commit where we did the completed the subtract function. Now once again, just to point out, this unique hash is now different. So we once again changed the get history. So just one more time, just to remind you, only do this type of thing if you haven't pushed your changes yet to other people. So now if I do a get log and then I do a get branch, so now we see our subtract feature branch. And now just say that it hits us all of a sudden that we've been making all of these commits to the master branch by accident. Really, we've been meaning to make these commits to our subtract feature branch. Now this is a fairly common mistake to commit to the wrong branch, because when you switch back and forth, sometimes you just forget exactly where you are and end up committing to the wrong branch by accident. So how do we move this commit right here, this 1B818, how do we move that commit to our feature branch? Now to be clear here, exactly what we want to do is our goal is to move this commit to our subtract feature branch, and then we want to return our master branch back to the state of only having the single initial commit. So the way that we're going to do this is we're going to use get cherry pick. And cherry pick creates a new commit based off of our original. So in this case, our original is going to be this top commit here. Now cherry pick only creates a new commit based off of that commit. It doesn't delete the original after it cherry picks it. So let me clear my screen here. And so the process that you go through to do a get cherry pick is first you want to do a get log because we want to grab the hash of the commit that we want to cherry pick. So we don't have to grab the entire hash. Usually 6 or 7 characters is fine. So I'm just going to copy this here. And now I want to do a get checkout on my subtract feature branch. So now I'm going to switch to my subtract feature branch. And now from that branch, if I do a get log, you can see that we only have the initial commit. Now I'm going to do a get cherry pick, and I'm going to paste in the hash that I had copied from the master branch. So now if I hit enter there, and now I do a get log, now you can see that we brought that commit for the complete subtract function. We brought that commit over to our subtract feature branch. So now we have that commit on our feature branch, but it still exists on our master branch because cherry pick doesn't delete commits. But we don't want that commit on our master branch. We never meant to commit it there to begin with. So how do we get rid of it? So to do this, we're going to use a git reset. So I'm going to do a git checkout on master, and now I'm going to do a git log so that we can see the commits that we have. Now there are 3 different types of resets that we should know about. These are git reset soft, git reset mixed, which is the default, and git reset hard. So first, let's run through all of these. So first, let's run git reset soft to try to return to our initial commit. So I'm going to grab the hash from this initial commit and copy that. And now I'm going to do a git reset -- soft, and then I'm going to paste in that hash of our initial commit. So now if I do a git log, you can see that we no longer have that second commit, which is good. That's what we wanted. But let's also look at our git status. Now you can see that we have some files in our staging area. So soft will reset us back to the commit that we specified, but it will keep our changes that we've made in the staging directory. So we didn't lose any of our work. So in this case, our work refers to the addition of the .gitignore file and the modifications that we made to the calc.py file. So that is a soft reset. Let's look at a mixed reset, which is the default. So again, I'm going to grab the hash of the initial commit, and this time let's do a git reset, and I'm just going to paste in the hash because without any additional options, it will default to mixed. So let's go ahead and run that. And now let's look at our git log. We only have the 1 commit, which is good. But now if I do a git status, you can see just like git reset soft, it kept the changes. However, now these changes aren't in the staging area. Now they're in the working directory. So it's very similar to git reset soft, but the files are either put in the staging or working directory based on which one you specify. But in this example, we really don't want our changes. We really just want to go back to that initial commit and have everything the way that they were. So again, let's copy the initial commit hash, and this time we're going to try a git reset hard. So git reset hard is going to make all of our tracked files match the state that they were in at the hash that we specify. And you have to be careful with git reset hard because it will get rid of your changes. But in this example, that's what we want. So I'm going to do a git reset -- hard and paste in that hash. And now if I do a git log, you can see that we have the 1 commit. And now I'm going to run git status. So notice that the modifications that we made to the calc.py file are gone, but that the .gitignore file is still there. Now, if you remember, I said that the git reset hard reverts all of the tracked files back to the state that they were, but it leaves any untracked files alone. So we can see here that we still have some leftovers with the git reset hard, but luckily getting rid of untracked files is extremely simple. So to get rid of untracked files, we can just use git clean. So if I do a git clean, and then I'm going to specify the D and the F option. So the D option gets rid of any untracked directories, and the F gets rid of any untracked files. So if I run that, now if I do a git status, you can see that our working directory is clean and that .gitignore file is gone. Now that clean command is a good command to know because it actually comes in handy more often than you'd think. For example, one time I accidentally unzipped a file within my Git repository, and it created just a ton of untracked files and subdirectories. And I could have gone through and tried to pick all those out manually and delete all of them, but the easiest way to remove all those untracked files is just with this single git clean command. Okay, so we learned that the git reset hard totally deletes all of our changes. But what if you accidentally ran that and it turns out that you did need some of those changes? So let's pretend for the sake of this walkthrough that we don't have those changes still saved to the subtract feature branch, and we thought that the reset deleted all of the changes that we've made. So if you did run a git reset hard on some changes that you really needed, then are you completely out of luck? Well, not entirely. So you could be out of luck if a lot of time has gone by since you ran that git reset. I don't know the exact amount of time, but I think git garbage collects those commits after 30 days or so. But git ref log is what we're going to want to use here. So git ref log shows commits in the order of when you last referenced them. So let me run a git ref log here, and you can see that it kind of shows us exactly a walkthrough of exactly what we've been doing. So you can see here at the bottom is where I made my initial commit, and then we committed our complete multiply function, which was wrong. And then you can even see where you amended commits. So this was an amended commit where we changed our message, and another amend, that's where we added the .getIgnore file. And it shows us that we checked out and moved from master to subtract feature, and then did our cherry pick and our checkout, and then our reset. Now, if you'd accidentally got rid of files that you didn't mean to get rid of, then, so for this example, I'm going to grab the hash before the reset and copy that, and I'm going to do a git checkout of that hash. And now from here, I'm going to run a git log. So you can see when I run a git log from this hash that we have our changes back. This is the commit that we reset and got rid of all those changes. Now right now we are in a detached head state. Now I'm not going to go fully into what this means, but basically it means that we aren't on a branch. And where we currently are, it will be trashed at some point in the future. So to save these changes, we need to make a branch from it. So from here, I'm going to do a git branch, and I'm just going to call this backup. And now if I run git branch command to look at all my branches, you can see that currently we're in a detached head state, and we'll get garbage collected at some point. And now we have our master branch, our subtract feature branch. We also have this backup branch. So now let me check out the master branch. And now from the master branch, if I do a git branch, you can see that we still have our backup branch. So those changes that we thought that we'd lost, now we have those in this branch here. So just to confirm that we still have those changes, let's do a git checkout of that backup branch. And now from here, let's do a git log. And now you can see that we have those changes that we thought that we'd lost. So the git ref log can really be a lifesaver if you thought that you had lost some critical files that you really didn't mean to delete, or that if you accidentally did a reset on something, the ref log can really help you out if you know how to use it. Okay, so in these examples so far, I mentioned that you shouldn't change the git history if other people have pulled those changes already. Well, what if you are in a situation where you really need to undo some commits, but other people have already pulled those changes? So in a situation like that, you're going to want to use git revert. Revert creates new commits to reverse the effect of some earlier commits. So this way you don't rewrite any history. Just to clarify that, it's not going to modify or delete our existing commits that we've made. It's going to create new commits on top of those that completely undo all of the changes so that our history remains intact. So just to show an example of this, I'm going to run a git log, and you can see that we have our two commits here. So now what if this completed subtract function, I wanted to undo that, but other people have already checked that out? Well, I can just copy the hash here, and I'm going to do a git revert and then paste in that hash. And now it's going to come up here with a message, and I'm just going to save that and exit out of that. And now if I close out of there and do a git log, you can see that we now have 3 commits, and these 2 bottom commits are completely untouched. Both of their hashes are still the same as they were before the revert. Now we have this additional commit that says that it reverted the complete subtract function. So if I go over here to my calc.py file and reload it, you can see that it undid that return statement that we typed in. Now, one nice little trick with the git diff command is that if I do a git log here, and then I do a git diff of this hash and this hash here, it's going to show me the difference between the complete subtract function commit and then the reverted version of that. So you can see that whenever I compare these two commits, all it did was go in here and it saw all the changes that we made in our complete subtract function commit, and then it just redid or undid those. So for that commit, we took out the pass line and added in the return x minus y line, and in the revert, it took out the return x minus y and added in the pass. So it just did the complete opposite. So now whenever you push these changes and somebody else pulls those down, their history is not going to be corrupted because all of this history is the same, and all they're going to get is these new commits that undid those previous commits. Well, that about does it for this video. I hope that these Git tips on how to undo some of your mistakes and roll back some previous commits, I hope that this was useful for you all. If you do have any questions, just ask in the comment section below. Be sure to subscribe for future Git videos, and thank you for watching.